Hi, today we're going to look at elements and compounds and mixtures and how they're represented through chemical formulas. So let's get started. You can take notes during this presentation. You can also use the fill-in notes provided for guided note-taking. So let's think about what we already know. What are elements? So elements are pure substances. They are made of only one kind of material. So that kind of atoms in an element, there's only one kind of atom. And even down to that single atom, elements have definite properties and they're the same all throughout. So every atom in an element has the correct number of protons for that element. They're all that kind of atom. So they cannot be broken down or into a simpler substance without losing their identity. So sometimes we can break atoms apart, but then they are no longer the thing that they were before. So they cannot be broken without losing their identity, and they are represented by a symbol. So those are the symbols that we see on the periodic table. The symbols have a capital letter, a single capital letter, or it's a capital letter followed by a lowercase letter, and there would be just two letters for that. So an example would be magnesium or sodium. And then these are the elements that are on the periodic table. So now, what are compounds? Compounds are made of two or more different elements, and they are chemically combined. So we have examples of compounds that we are familiar with. Think about water. We know that water is H2O, or nitrogen oxide is NO. Carbon dioxide we know a lot about, carbon and two oxygens. And these are chemically combined with one another. And these are represented by formulas. Again, H2O, we understand. NaCl, that's table salt that you put on your food at your table, the white stuff, right? NaCl, sodium chloride. Then we have C6H12O6, which you may or may not know is glucose, which is a simple sugar that our cells use to metabolize. It's created by the process of photosynthesis in plants. And then, of course, carbon dioxide, CO2. So compounds have different properties than their original elements. So if we think about hydrogen and oxygen, those two things are both gases, right? Hydrogen and oxygen. But H2O is water. It's a different compound. It has different properties than the two original elements that make it up. So that's a key idea, is that compounds have different properties than their original elements. So they cannot be separated by physical means. You can't just take water and cut the hydrogen away from the oxygen. We can't just easily break it apart without a chemical reaction. We use a chemical, they are chemically bonded, and so they can only be taken apart chemically. So unlike elements, compounds, they can be broken down into similar substances through that chemical reaction. So they can be broken down into, like water, could be broken down to hydrogen and oxygen, but not without a chemical reaction. So when we think of compounds, the properties of the elements that make up a compound are quite different, as I said, from the properties of the compound itself. So if we think about table salt, the stuff that you put on your food during a meal, it's made of sodium. So sodium on the periodic table, it's in the alkali metals. It's highly reactive. It has one valence electron, which means it's very, very reactive. And chlorine is, well, so it's a metal. So we know what metals are like, right? Metals, they're shiny, they're hard, solids, they are good conductors of electricity. So think about metals, right? That's what sodium is on its own. Now chlorine is a poisonous gas. It sits over on the other side of the periodic table. It has 7 valence electrons, so it creates a bond, a chemical bond with sodium. It's an ionic bond, we'll get to that. But it creates a bond with sodium and chlorine together, and so we get sodium chloride. So together, we take this metal and this poisonous gas and we combine them and put it on our food and it tastes great. So you can see, I always keep this example in my mind when I think about how compounds have different characteristics than their elements that make them up. So think about a compound as a new substance. It's something different, it's something new. Now, molecules. What do we know about molecules? How are molecules different? A molecule is two or more atoms chemically bonded that act like one unit. So water is two atoms of hydrogen and one atom of oxygen. So we can see in the image here, we have two, we have these hydrogens are here, and this is oxygen. And then together they make these water molecules. Now you can see how these two oxygens are together and the two hydrogens are together before it even begins. So two atoms of hydrogen and one atom of oxygen, whoops, my bad. Together they form H2O. So all compounds, since they are atoms chemically bonded together that act like one unit, all compounds are molecules, but not all molecules are compounds. So the H2 right here, the white ones, the H2, they would be molecules because it is two atoms that are bonded together that are acting as one unit. The O2 is also a molecule. It's acting as one unit. But these are not compounds because there's only one kind of atom. There's only oxygen atoms, only hydrogen atoms. So if it's two that are together that are the same thing, then that's only a molecule. It's not a compound. If you think about compound as, think about what you know about the word compound. A compound sentence is like two sentences, two different sentences combined. A compound word is two words like rainbow. That's a school bus. Well, school bus is not a single word. Never mind, that's a bad example. So rainbow would be rain and bow. So it's two words. You can put them together. That's a compound word. So in the same way, a compound is two different elements combined, chemically bonded together. But a molecule can just be any two atoms, even if they're the same, combined together. So H2 is a molecule, but not a compound. But H2O is both a molecule and a compound because it has two different elements. So a quick check. Which substances are molecules and which substances are both molecules and compounds? So our O2 would be just a molecule. CO2 would be both because it has different elements. C6H12O6 is both, and then Cl2 would be just a molecule. So now we have to represent these different molecules or compounds in some way that we can understand. So a shorthand way of representing these compounds is called a chemical formula. These are what we've been talking about, like H2O is a chemical formula. So if the chemical symbols are the letters combined, then formulas are the words. They are what makes up, and they have specific meanings. So NH3 is ammonia. C3H7OH is what we know as rubbing alcohol. So sometimes the formula represents a molecule of a single element. These are called diatomic molecules. Remember, di means two, right? Diatomic, two atom molecules. This is how the element is naturally found in nature, naturally found in nature. So you can see the examples here. We have hydrogen, nitrogen, oxygen, fluorine, bromine, iodine. All of these naturally occur in diatomic molecules. So we often get O2 is oxygen. Just single atoms of oxygen don't float around by themselves. They combine with another atom of oxygen when they are on their own. So that's what diatomic molecules are. Now, it's very important that you understand what the numbers mean when we're talking about different elements and when we're talking about compounds and chemical formulas. So the little numbers that you see are called subscripts. So they show the element's number and the number of atoms of each element in a molecule. For example, let's take a look at this one. H2SO4. So there are 2 atoms. Actually, let me turn this off. 2 atoms, these are the white ones, of hydrogen. So you can see hydrogen is 2. Sulfur, whenever you see nothing next to it, you can assume that's a 1. That's the yellow one. Sulfur is 1 atom. And then oxygen, that's the red ones in the picture. You can see oxygen here. There are 4 oxygens. So in this chemical formula, there are 7 atoms total. And these subscripts tell us how many of each of the element are in the whole formula. Now, this creates a molecule or a compound. And remember, it's chemically combined, so we can't just go breaking it up for no reason. It has to stay together unless a chemical change happens. So we can never change the subscripts when we are balancing equations. We'll get into that later. But if we change one of these, then it's going to change what the actual compound is, and we can't just haphazardly do that. Now, coefficients, on the other hand, are a number that is out in front of the formula. So if the formula begins with a number, then that's called a coefficient. If there's no number, then it's understood to be 1. In the same way that if there's no subscript, we assume that it's 1. So the coefficient represents the number of molecules of that compound or atom needed in a reaction. So when you see a 2 out in front for this example, the 2 is the coefficient, and it's going to represent 2 whole molecules. So if you had 2 whole molecules of sulfuric acid here, 1, 2, and each of them has this particular formula, 2 hydrogens, 1 sulfur, and 4 oxygens, then you could kind of figure out how many oxygens total are there. They're the red ones, remember? So oxygens, we have 4 here and 4 here. So how many total are there? That's right, there are 8. And so you can see here, oxygen 4 and 2, you're basically multiplying to find the number of any particular atom, and you're multiplying by the coefficient to find out, because you can imagine when you're thinking of these, you need to imagine what it looks like in your head. Even if you don't have the exact picture, imagine that it's like a whole molecule that has to stay together. So let's keep taking a look. So we're talking about coefficients continued. When we have 2 H2SO4, the example before, we have 2 molecules of the sulfuric acid. So the coefficient, as we said, is distributed to all the elements in the compound. So to find the number of atoms, you would need to multiply 2 times 2 hydrogens is going to give you 4 hydrogens. 2 sulfur atoms, here, there's just 1 sulfur in the formula, but we have 2 whole molecules. So 2 times 1 is going to be 2. And for oxygen, as we said, there were 4 in a single molecule. And since we have 2 molecules, that is 8 atoms. Now we've mentioned that in a compound or in a molecule that atoms are actually bonded together chemically. But how do atoms join together? So a chemical bond is an interaction that holds atoms together. This is known as a molecule, which is mentioned earlier. When we talked about valence electrons, we learned that if the outer energy level is not full, that an atom seeks to either gain or lose electrons in order to be stable. So atoms form bonds with other elements, or sometimes with other atoms of itself, in order to lose or gain electrons to be, we say, happy or stable. And we think about that octet rule, so that an element has 8 electrons in its outer shell. So bonds are formed then to get the atoms to a lower energy state so that they are more stable. One kind of bond is called a covalent bond. These are bonds between two nonmetals, so two oxygen or carbon dioxide, two things that are both not metal. Nonmetal to nonmetal, covalent bond. So as attractions bring the atoms together, electrons from each of the atom are attracted, because remember, electrons have a negative charge. They're attracted to the positive nucleus, both of their own nucleus, the positiveness of their own nucleus that kind of holds them in, but then also they get attracted to the nucleus of another atom. And then the electrons actually are shared between the two atoms, and they create a bond. They sort of hold together. The sharing of these electrons then is called a covalent bond, and it holds it together. When atoms are covalently bonded as a molecule, they're more stable than they were as separate atoms. That's why they tend to go into that state of covalent bonds. So examples then are hydrogen, like I said, oxygen, H2O. Those are both nonmetals. O2, CH4, carbon dioxide. Now let's look at ionic bonds. So ionic bonds are bonds between metals and nonmetals. So when a metal bonds with a nonmetal, that's when we get an ionic bond. So remember, covalent is two nonmetals, and ionic is between a metal and a nonmetal. So ionic bond is a complete transfer of valence electrons. It's when the electrons transfer from one atom to another. So in an ionic bond, there's an electron donor, the atom that is giving its electron away, and there's an electron acceptor, an atom that's receiving the donated electron. So it's a type of chemical bond that generates two oppositely charged ions. Now remember, we said an ion is when the number of protons in the nucleus is different than the number of electrons. And so you think about it, if we have a neutral atom and one of the electrons goes away, then that atom then becomes positively charged. And so if the atom receives, then it's going to have a negative electron, an extra negative, then it's going to become a negative ion, and then those would attract to each other. So ionic bonds, the metal is typically the one that loses the electrons, because remember, metals are on the left side of the periodic table. If you think about our alkali and our alkaline earth metals, they have 1 and 2 valence electrons. They would want to be getting rid of those valence electrons, and they would easily bond with something from the other side that has 6 or 7 valence electrons. So something with 6 would very happily accept 2. So that's typically how that happens. So take a look at the videos that you can see on this later. Chlorine is a greenish poisonous gas, like we said before, and sodium is this soft, shiny, very reactive metal. But when they react, they form sodium chloride, just normal table salt. So in the video, a drop of water helps expose the atoms at the surface of the sodium so they can react with the chlorine. So during the formation of this salt crystal, it's an example of this ionic bond happening. An electron is transferring from the sodium, which has 1 valence electron, to chlorine, which has 7 valence electrons. So the sodium becomes a positive ion, and chlorine then becomes a negative ion because it gains an electron. So then positive and negative attract to each other, and that forms that ionic bond. And when the bond is formed chemically, then we have a new substance, which is our sodium chloride.